The outcome that we are going to look at over the course of the next few lessons is probability and odds. The essential question we want to be able to answer is, how are probability and odds related? So what do you think about that right now? How do you think that those two terms are related? What we're going to do is we're going to see if your answer to this question changes after we've looked at the two of them in depth. A fair game is a game in which all the players are equally likely to win. For example, tossing a coin to get heads or tails is a fair game. Each of those has an equal chance of occurring. So I want you to look at this. Kim and Aaron have to invent a fair game for a class project. Kim suggests this game. 2 people will play it. Both players put 3 identical slips of paper, numbered 1, 2, and 3, into their own container. So they each have their own container, and they each have 3 slips of paper with the numbers 1, 2, 3 on them. For each turn, both players draw 1 slip of paper from their container. Player 1 will score a point if the product of the 2 numbers drawn is less than their sum. So let's recall. Product is what happens when you multiply the 2 numbers. Sum is what happens when you add the 2 numbers. So player 1 wins if the product is less than the sum. Player 2 scores a point if the product of the 2 numbers drawn is greater than their sum. So player 2, if the product is greater than the sum, they score. Neither player gets a point if the product and sum are equal. After each turn, the players return their slip of paper to their container, and a game consists of 10 turns. Would you rather be player 1 or player 2? And is Kim's game a fair game? So why don't you pause the video here and think about that. Maybe do a few trials and see what would actually occur. Play this game. Once you've played it and you have your answer, then continue the video. All right, so hopefully you've paused and you've thought about this and you have the answer. Let's have a look at what actually happens. So we've got a few trials here to see what happens. These are all of the possibilities that could occur. All right, so as you can see, player 1 could draw 1 3 times to players 2, 1, 2, 3. Player 1, they could draw 2 to player 2's 1, 2, 3, etc. So these are all of the possibilities that could occur. Then we have the product of what would happen and the sum of what would happen, and let's look at who would be the winner. Now remember, in a fair game, each person has to have an equal chance of winning. Is that the case here? The answer is no. Player 1 wins 5 times. Player 2 only has 3 chances of winning. So it is not a fair game. If it was to be fair, they might both be able to win 4 times, or 3 times, or 2 times, whatever the case might be. But when one person has a better chance of winning, in which case player 1 does, the game is not fair. Sample space is the set of all possible outcomes. For example, if we rolled a 6-sided die, the sample space would be 1, 2, 3, 4, 5, 6. In the previous Explore that we were looking at, the sample space would have been all of these possibilities. So the person could have got, player 1 could have had a 1, player 2 would have had a 1. Player 1 could have had a 1, player 2 could have had a 2, etc. That would have been your sample space for this question. The event is the set of favorable outcomes. So for this example, rolling a number less than 3, we're still looking at the 6-sided die. Numbers that are less than 3 are 1 and 2. So that would be classified as the event. In the previous example in the Explore, maybe the event is that player 1 wins. So then we would list all of the possibilities where player 1 would win that round. So let's see if we can take those definitions and put them into a question. An 8-sided die with sides numbered 1 through 8 is rolled. Write out the sample space. So we've got an 8-sided die, and it's got the numbers 1 through 8. So the sample space is simply listing all of the possible numbers that could turn up. Write out the event that the number rolled was odd. So we look at our sample space, the 1 through 8, and we write out the event where they are odd numbers. So 1, 3, 5, and 7. Write out the event that the number rolled was a prime number. So remember, a prime number is a number that only has 1 in itself as factors. 1 is not classified as a prime number. It is a unique number. So we've got 2, 3, 5, and 7. Those are all prime numbers from our sample space. Write out the event that the number rolled was larger than 8. Well, if you look at our sample space, there is nothing larger than 8. So we have the empty set. Experimental probability. This is not new. You have looked at experimental probability in past math classes. So let's just review what it's saying. The probability of an event is equal to the number of successful events divided by the number of trials. So if you're tossing a coin 20 times and you want to see how many times you get heads, you roll or you toss the coin 20 times, that's your number of trials, and if heads turns up 8 times, that's the number of successful events. So it would be 8 out of 20. Here's another example. A basketball player attempts 25 free throws and sinks 18 of them. So the probability of making a free throw is 18 out of 25. In experimental probability, the more trials you attempt, the more accurate the probability will be. And in something like tossing a coin, we know that you have a 1 in 2 chance of getting heads, or a 1 out of 2 chance of getting tails. But if you actually toss that coin 5 times or 6 times, you might not get exactly half of them heads and half of them tails. But the more you start tossing this coin, the closer it's going to get to that 1/2 probability. The probability of an event will always be between 0, which is impossible, and 1, which is certain. So you're not going to have a probability greater than 1 or less than 0. An event that could never happen is 0, so that's impossible. And an event that is certain to happen is 1, so it's absolutely going to occur. You can express probability as a fraction, a decimal, or a percent. Theoretical probability. So this is what would happen in theory. Probability of an event is the number of outcomes in the event divided by the number of outcomes in the sample space. So if we think back to when we were looking at the definitions there, and we were rolling a 6-sided die, so we had our sample space was 1 through 6, so there were 6 in the sample space. And the event that it was less than 3, it was just 1 and 2. So there were 2 numbers in the event. So the probability would have been 2 out of 6. The probability of an event occurring can be represented as P brackets whatever that event is. So in this case, we're going to call it an E. The complementary event is the probability that that event does not occur. And we use the prime notation to represent the complement event. One thing to keep in mind, probability of an event occurring plus the probability of it not occurring is always going to equal 1. Or if you're in percentages, it will always equal 100%. Because an event is either going to occur or it's not going to occur. So the total of those two together would be 1. The other way you could look at it, if you know the probability of the complement, or the probability of the event, you can find the probability of the complement by going 1 subtract the probability of the event. So in this example, if the probability of some event is 7 out of 11, what will the probability of its complement be? All right, some of you can probably answer this without even doing any written work. All right, because remember, the probability of the event plus the probability of the complement equals 1. So what we could do, we could go 1 subtract 7 minus 11, which becomes, if we're showing every step, 11 minus 11 over 7 minus 11, which is 4/11. So the probability of the complement is 4 out of 11. Now, as I said, you could do this simply without showing all of that work. You just ask yourself, 7 plus what is 11? It's 4. And so we're now 4 out of 11. We still have the same sample space in both cases. All right, if we think about a standard deck of cards, there are 52 cards in this deck, and they're separated into 4 suits. If you are not familiar with cards, you may want to pull out a deck of cards to have them out there and look at them to see what all occurs. Find the probability that the card selected is red. So red are hearts and diamonds, and there are 13 of each of them. So there are 26 red cards in a deck out of 52 cards. And that can be rewritten as 1/2, or 0.5, or 50%. Because remember, we can write it as a fraction, a decimal, or a percentage. So any of those would be acceptable. A club. There are 13 clubs in a deck of cards. There are 52 cards. This can be reduced to 1 out of 4, or 0.25, or 25%. You can express it in any of those forms. A face card. Face cards are jacks, queens, and kings. There are face cards, jack, queen, and king in every suit. There are 4 suits. So there are 12 face cards. So 12 out of 52 are face cards. That reduces to 3 out of 13. So we can write it as 3 out of 13, or that can be written as 0.23, or 23%. Now that is an approximate because 3 out of 13 is not a terminating decimal. But that's okay. You can round it to the nearest hundredth and make that approximation. All right, we want to find the probability of drawing a king. There's 1 king in each suit. There are 4 suits. So there are 4 kings out of 52 cards. That can be simplified to 1 out of 13. So we can write it as 1 out of 13. Or we could write it as 0.08, or approximately 8%. And again, that is an approximation. And the last one, the 7 of spades. There is only 1 7 of spades in a deck of cards. So we can write it as 1 out of 52, or we can write it as 0.02, or 2%. So probability will always be between 0 and 1. You can write them as fractions, decimals, or percentages.